Hello and welcome in a new video. We will solve now an exercise of dynamics involving the friction force. So let's start with this exercise. A block is deposited at A using a conveyor belt at a speed V equals 0.8 meter per second. The incline has an angle theta equal 30 degrees with the horizontal. So we have a block A deposited at A here on a conveyor belt. So we have here like a tapis roulant where we deposited a particle at A. So V at A is equal to 0.8 meter per second. The incline has an angle theta equal 30 degrees with the horizontal. So A will go through this incline. So from A to B, the incline makes an angle theta equal 30 degrees with the horizontal. The question is, calculate the distance S at the surface BC. This is a horizontal surface where the block stops. So basically the mass will go from A to B and then from B and it will continue towards C. At a certain distance S, so at C, the block will stop. They want us to find what is S. So the length of BC, they want us to find BC. The coefficient of kinetic friction between A and C is mu k equals 0.3. So we have a friction from A to B and from B to C. So in this exercise, we need to find S. It's the distance traveled from B to C, where VC is equal to 0. So how can we find BC? I suggest to start with Newton's second law on BC. Okay, so here we can distinguish the motion along AB and the motion along BC. So let's start with the motion from B to C and see what are the quantities that are needed to be found. So from B to C, we have the main forces on the particle from B to C are the normal reaction, friction, and the weight. So N plus F plus mg is equal to ma. The normal and weight are both vertical. N is upward and mg is downward. Friction, the friction force is always opposed to the motion. Since we have motion to the left, then the friction force should be directed to the right. It's equal to ma. Since we have a friction, I suggest to start the projection along y to find n, because F is related to the normal reaction, and the normal reaction can be found by projecting the Newton's second law along y. So let's start with the projection along y. So the idea is, wherever you see the friction force, start to make the projection along y. So we will have plus n minus mg is equal to 0. So the acceleration along y is 0 because we don't have any motion along y. So here we took the positive y direction as upward. So we will have n minus mg equals 0. This means that n is equal to mg. And the friction force is equal to mu c times n. So mu c is the same as mu k. K stands for kinetic, the kinetic coefficient of friction. In French, it's called mu c. Mu, c'est cinétique. In English, it's called mu k. Mu, kinetic mu. So F is equal to mu times n. And n is equal to mg. So we obtain that F is equal to mu times m times g. Okay. We have now the friction force. We can project along x. So along x, we just have the force, the friction force along x, and this is equal to the projection of F along the x-axis will give minus F equal max, and max is equal to A. Let's substitute F with mu mg, so minus mu mg is equal to ma. This will give us that A is equal to minus mu times g by simplifying with m. And we can notice that mu is a constant and g is a constant, so the acceleration is a constant. It has a negative value because we just have the friction force that is applying here on the particle. F is directed, it's opposing to the motion, so the acceleration is negative. But here, there's something very important to notice. The acceleration has a constant value. So since the acceleration has a constant value, we can use one of the 4 equations of the constant acceleration model. What is important to be found here? They want us to find S. So it's a distance. What do we have as an equation relating the distance to the acceleration? So let's use Vc squared minus Vb squared equal 2a times the distance traveled from B to C. So we can deduce S if we know Vc, if we know Vb, and if we know the acceleration. So the acceleration here, A refers to the acceleration from B to C. We know what is the acceleration from B to C. Do we know Vc? Yes, because it's equal to 0, because at C the particle stops. Do we know what is Vb? No, we don't have any information about Vb, but we know that Vb is the initial speed for the motion along BC, and Vb is the final speed for the motion along AB. So let's study now the motion along AB and deduce Vb, and then once we have Vb, we can replace Vb with its numerical value to find S. So now let's study the motion from A to B by applying Newton's second law. The objective is to find Vb. Okay, on the incline AB, the fundamental relation of dynamics will give us the normal force, the friction force, and the weight. Their sum is equal to ma. So once again, because we have a friction, let's study by projecting this equation along the y-axis. Okay, so what is the y-axis and what's the x-axis? So here we choose to draw the x-axis as the direction of motion. It's oblique to the left, and y is perpendicular to x. So along y, n will give us, the projection of n along y will give us plus n. F doesn't have any projection along y because F is perpendicular to the y-axis. Now mg, what is the projection of mg along y? Is equal to minus mg sine of this angle. And this angle is equal to this angle, corresponding angles. And we can deduce from this right triangle that the red angle is complementary to the 30 degrees. So the red angle is equal to 60 degrees. Then the projection of mg along y is equal to minus mg sine of 60 or minus mg cosine of 30 degree equal MAY, and here AY is equal to 0 because the object cannot move on the y-axis. It can only move along the x-axis. So this means that the normal reaction along AB is equal to mg cosine 30 degree. We can deduce the friction force, which is equal to mu c or mu k times n. This is equal to mu mg cosine 30. Now we have to make the projection along OX. So the projection along OX, the projection of n along OX is equal to 0. The projection of F along OX is equal to minus F. And finally, the projection of mg along X will give us now plus mg cosine of 60, so plus mg sine of 30. And the acceleration along X is equal to A. Now let's replace F with mu mg cosine 30. We can simplify by m, and we can finally obtain the acceleration along AB. The acceleration along AB is equal to g sine 30 minus mu g cosine 30. We know what is g. It's equal to 10 meters per second squared. We know what is sine 30 and what is cosine 30. We know the value of mu c or mu k. And finally, we can notice that the acceleration has a constant value because g, the angle is constant, mu is constant, so the acceleration is constant. This means once again that we can use one of the four equations to find the needed quantity. What do we need to find from AB? We just need to find what is VB. And VB is the final speed for the motion along AB. So once again, we will use this equation. So VF squared minus V initial squared equal 2A times the distance traveled. So V final here is VB. V initial is VA. The acceleration here is the acceleration along AB. And the distance traveled is AB. Okay, we need to find VB. We know what is VA because it's given that V, the initial V at A is 0.8 meters per second. We deduced the acceleration along AB. And we know the distance from A to B. AB is equal to 2 meters. Then VB is equal to 3.2 meters per second. This numerical value of VB will be used in the expression here of S, which was BC. So we know VC, it's 0. We know VB, and we know the acceleration along BC. Then finally we can deduce the value of S, or the distance BC. Finally, we obtain that S is equal to 1.7 meters. So 1.7 meters is the distance BC where position C corresponds to the position where the block stops. So VC is equal to 0. So if we want to now summarize this exercise can be divided into two motions. We have a motion along AB and a motion along BC. These are two different motions, but they have one common point, which is B. For the motion along AB, B is the final position, final point. From the motion along AB, we deduced VB. And from the motion along BC, we deduced the distance BC, where BC is the distance traveled before the particle stops. So I want to draw your attention to the fact that wherever you see a constant acceleration, you have to stop and think, we have a constant acceleration, then we can use one of the four equations of the constant acceleration models. These equations are v final squared minus v initial squared equal to a times the distance traveled. The second equation is x equal half a t squared plus v0 t plus x0. And the third one is v equal at plus v0. Now we have also a fourth equation, which is a combination of the previous equations.